All right, this lesson is 4.2 on implicit differentiation. So far we've had y being set by itself. So when you take the derivative, it's just y prime equals blah, blah, y prime or f prime of x equals something, right? So it's not always that our function is so clean that y is by itself. So sometimes the y is embedded into our equation in standard form or whatever other form. For example, an ellipse, right? It's x squared plus y squared, x squared over something plus y squared over something equals 1, or a hyperbola x squared minus y squared, something like that, right? Or even just a circle, x squared plus y squared. So these functions are where x and y are on the same side, or y is a part of your equation. Y is still a dependent variable. It's dependent on the x, right? X is your independent variable. It's whatever we plug into the x, that is going to spit out our effect on the y. So when you take a derivative, these y have a derivative of their own. They have a y prime of their own. So again, the application of it, the way to approach this is to just keep in mind that whenever you're taking a derivative of y, you need to add a y prime whenever you differentiate it, because when you are working on that y, it has a y prime, it has a derivative that is dependent on the x, so you need to kind of address that. Again, so it's kind of a weird way to explain this, and I'm sure there are many other ways, many better ways of explaining it, so I'm very okay with you searching on the web for a better explanation. But how to do it, how to approach this is how we do it, all right? So in the first problem here, I have y squared equals parentheses 1 minus 6x to the 2/3 power. So you're going to take the derivative on the left-hand side. You're going to treat this y squared like a normal variable, like an x squared. What do you normally do? You drop the 2 down, power rule, 2y. But because you dealt with a y here, you have to have a y prime with it. So 2y, y prime. And then on the right-hand side, you take the derivative as you normally do. So drop down the 2/3, and then parentheses 1 minus 6x, and the whole thing to negative 1/3 power. This is chain rule over here. And don't forget the inside here has a negative 6x here. So you need to take out a negative 6 for the derivative. So notice how my y prime is in red here. So when I do these problems, I usually have a red pen in hand. So whenever y prime pops up, I have to remind myself that, oh, there's a y prime here. And then the red just makes it really stand out for me. Sometimes I remind students that, hey, when you have two y terms in your equation, you will have two y primes when you pop out, right? So however many terms that have the y, you will have that many y primes. So since only one term here has a y, we'll have a single y prime here. So now our goal is to get y prime by itself, because so far that's what we've been doing. We've been solving for the first derivative. So you're getting y prime by itself. All right, so I'm going to clean up both sides. I'm going to clean up algebraic on the right-hand side and try to keep my 2y with a y prime still, right? And then so in my last step here, I need to divide by 2y on both sides so that I can get y prime by itself. So I divide by 2 first to get rid of the 4, and then you can leave it as negative 2 over y. Or again, be comfortable in rewriting it correctly in terms of fractions. So negative 2 over y, 1 minus 6x to the 1/3 power. So keep your negative exponents as a denominator in your fraction, okay? All right. Number 2, now we're going to venture into some trig functions here, right? So the first term here, you have your x squared. And that's okay. You just take derivative as is. The sine y, now remember you have a y. So it's chain rule again. You take the derivative of the outside, sine becomes cosine y. Then the y has a derivative of its own, so y prime, right? And then the next term here has y squared, so it's 2y times y prime. And then negative cosine x, now derivative of that is going to be positive sine x. So my next line is going to look like this. Now, just as I mentioned before, this time in this equation, you have two y terms. Therefore, notice how in this next line here, we have two y primes, right? So the number of y terms should match how many y primes that show up in your next line. And now, again, your goal is to get y prime by itself, but because there's two of them, what do? Well, you're going to subtract, you're going to move this one over, or whichever one, doesn't matter. So I move this one over, and I move this one to the right-hand side. So that way everybody with a y prime stays on one side, everybody without stays on the other, because then now I can factor out the y prime from both terms and then divide it over so I get y prime by itself. Okay. All right. Next, you have your quotient here. So I went ahead and did some u prime, v prime. So I did the derivative of the top, which now becomes 1 minus y prime because x is 1 and y derivative of y is y prime. And the bottom is 1 plus y prime. Now, if you don't need to do that, it's okay. You can do your low d high minus high d low. You get the same exact thing. You can do vu prime minus uv prime or v squared, same thing. In any way, your next line should be exactly the same here. So you should have your low d high, right? vu prime minus u v prime all over v squared equals, the other side is 2x. Oh, I lost my parentheses here, so I'm going to keep that in here, right? So you have your x plus y squared, like so. All right, so now this gets a little trickier because you want y prime by itself, right? So what should you do? First thing I'm going to do is multiply this over so that it is on that side. That way I don't have fractions. Next thing, I need to make sure I distribute all these and multiply all these out, okay? So first step, I multiply the x plus y to the right-hand side. Next, I distribute everything out on the top. So this gets a little bit trickier. And then I subtract. I distribute the subtraction and clean up, right? So I distribute the subtraction. And it actually cleans up really nicely. So I'm left with now just 2y minus 2xy prime, right? So if I divide by 2 on both sides, I would get nice single terms of x minus y minus xy prime equals x times x plus y squared. Most of the time, these won't have things that you can cancel out really nicely, like clean up really nicely. So I wouldn't really bother looking for them. All right, so I'm going to subtract the y and divide by the negative x, right? And again, some books don't like the negative x. So what happens is that when you divide by the negative x, you can use this negative to flip these two around. So notice how my next term now becomes y first, and then minus this whole thing, and then all over a positive x. Okay? All right. Now, this is a fun one. It says, now find the second derivative given that x squared minus y squared equals 5. So this is a, it's actually a hyperbola, but not that it matters. So you're going to take the derivative like you normally would. So I'm going to have 2x, right, minus 2y, y prime equals 0. Make sure you watch out for the 5. A lot of students will forget and put the 5 down, and that really mess up your answer, okay? All right, so we're trying to solve for y prime here. So I'm going to add the 2y, y prime to the right-hand side, and now divide by the 2y, so let the y prime be by itself. So I divide by 2 on both sides to clean this up a little bit, and again, this is another part where students mess up. They forget to clean up, to reduce, and then their numbers are huge, and then it's so hard to work with. All right, so your y prime should be a really nice clean x over y. Okay, now you want to take the second derivative, right? So you're going to take the second derivative of this function right here. This is a quotient. You have x divided by y. So I'm reminding you, use quotient rule to find your second derivative. And again, if you're comfortable with u prime, v prime, I'm going to remind you that u prime on top is 1, v prime on the bottom is y prime. So if I do low d high minus high d low over low squared, that is my y double prime. Now, when you do that, you see that you have a y prime that pops up again. Totally fine. So just make sure, see my hint here. You want to plug in your first derivative. This whole thing here, this x plus y here. Let me try to do this again. This x plus y here is equal to y prime. So you got to plug it in right here where y prime is, right? So I'm going to clean that up. I'm going to put that in, right? And you're going to clean this up as much as you can. And I'm sorry, there's a missing here. This is a y, not v. This is a y squared here, okay? All right, so I'm going to clean this up as much as I can by multiplying the top and bottom, and I think this is the quickest way of cleaning up this fraction within a fraction. I multiply by the denominator y over y. So if I distribute that and distribute and distribute, I get a very nice clean answer of y squared minus x squared, because then that second y reduces out, all over y cubed. So I get this really nice. You divide it. So what I did in the past was I put it into one fraction and then divided by the y squared. You get the same result. In any case, you get this y squared minus x squared equals y cubed. So what is really cool here, I remind you here that you need to substitute the original equation. So if you go back to the original equation, hey, it tells you that x squared minus y squared equals 5. But what I have is y squared minus x squared. I have the exact opposite. So instead of a positive 5 I'm going to plug in a negative 5. So you get a really nice clean answer of negative 5 all over y cubed. This is one of my favorite type of problems. So there's a good chance you might see this on a future assessment. Okay. All right, next, remember, we love these tangent normal problems, right? So I'm going to try to remind you to find how to find tangent normal to the curve, right? So what is really important is something like the second term here. Your x squared, no one has a problem. This minus 3xy, this is actually product rule. You got to remind yourself, you have two variables there, this is product there. So notice how in this original form, I have two y terms. Like two terms, I have a y. Therefore, when I take the derivative, I will have two y primes that show up. Okay, so let's see what I have here. I have 2x that came from the x squared. I take the root 3 outside because I really don't like to deal with that. I deal with the x times y just on its own as product rule. So I took the derivative of the x, that gives me the 1, and then the y stayed the same. Then I kept the x originally, and now the derivative of the y becomes y prime. So that's my product rule. Then I address this 2y squared, that becomes 4y, and because there's a y there, there's a y prime that shows up. And then the 5 gives me 0 because 5 is a constant. Okay, great. Now in the next step, I'm going to distribute a negative root 3 so that I can have each term on its own. And then I'm only keeping the y prime on one side while I keep the ones without y prime on the other side. I believe, in my opinion, it was much easier to move this over to be positive and this to be negative, but it doesn't matter which way you choose. And then in the next step, I can factor out the y prime on the right-hand side, and therefore go ahead and divide that over and get a really nice answer of 2x minus root 3 all over 3 root 3y, and then root 3x minus 4y. Okay. All right, so now I'm going to find slope because I'm looking for tangent, right? So I'm going to plug in I'm going to plug in root 3 and 2 into my x and y. So I'm plugging in the root 3 and 2, root 3 for x, 2 for y. So root 3 and 2, root 3 and 2, and I clean this up, and I get my slope to be 0. All that work to get 0. Sometimes that happens, all right? So if my slope is 0, then I use point slope form. I get y equals 2, right? And if you know that, then if y equals 2 is your tangent line, your normal line is going to be a vertical line, then that's going to be x equals something. So if you go back up and see your equation, if your tangent line is y equals 2, then your normal line is going to be x equals this root 3 right here. That is your other term in your point. So that's why x equals root 3 is your normal line for this one. Okay. All right, what if you have a different type of equation? We're going to practice 2 of these, right? So now I have this, and again, you need to remember this is x times sine of 2y. So not only is a product rule here, there's a chain rule here, there's 2y right here. Same thing, y times cosine of 2x. So there's product and chain, all right? So watch out for this first one, but you see I have my product and chain rule in here. And when I took the derivative of the sine of 2y, I have cosine of 2y. Then the 2y splits out a 2, and then because I dealt with the y, that's why there's a y prime here. Okay, same thing with the next term. I took the derivative of the y, so I kept the y prime, kept the cosine 2x here. Then y stayed on its own, and a negative 2 sine of 2x. Okay, clean up. And once I clean up with all those parentheses, I can see who has the y prime. So I kept the y prime on one side and the ones without y prime on the other side. Same step as always. Factor out the y prime and divide both sides. You get a really, really nice, well, not really nice, but this is your y prime at the end. Okay. Now, how do I find slope? Again, plug in the point to find slope. What is my point? Pi over 4 and pi over 2. So pi over 4 for x, pi over 2 for y. So plug in pi over 2, pi over 4 for my pi over 4 for my x, pi over 2 for my y. So clean up, 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 clean up. I get my y prime to be, oops, sorry. I have a parentheses here that I keep forgetting. I have my y prime to be 2. Wow, this is pretty nice. So I have a 2. 2 is my slope, right? So I use my points and slope to find equations. So I use my point slope form, plug in my 2, plug in my point of pi over 4 and pi over 2. I distribute. You can leave it like that, but I like to distribute and clean up, right? So I clean up and I get a really nice y equals 2x for my tangent line. Normal is opposite reciprocal, so my slope of 2 now becomes negative 1/2. I use that and use my point still of pi over 4 and pi over 2 and distribute, clean up, clean up. I get y equals negative x over 2 plus 5 pi over 8. Okay. All right. That's it for implicit differentiation.